Good morning, everybody. Good afternoon, good evening. Thank you to all for attending at this event and for the opportunity to present this topic. And let me first introduce myself. My name is Joaquín Reina. I am founder of the Biogas and Gases Technology located here in Barcelona, Spain. Our company is involved in biogas cleaning, biomethane production, odor removal, and in general in the waste treatment. We have more than 15 facilities working around the world, and I would like to present in this event this topic, the biogas cleaning. And inside the biogas cleaning, siloxane in the biogas, because siloxane is one of the dangerous components that appear in the biogas fluid. And I would like to present inside of the siloxane in the biogas, the origin, effect, and treatment, and treatment for the biogas fluid. For that reason, I propose these indices: introduction, topic, development. After this knowledge, show the cases study. In this case, the wastewater treatment plant of Butarque in Madrid, and what is the result of the cleaning and the end of the conclusion. Okay, what is the biogas? There are many definitions related with the biogas, but for all people relate, or all staff relate, or all engineering group relate with the biogas cleaning, biogas is a gas mixture that has two main parts. One part, the major part, methane, carbon dioxide, oxygen, hydrogen, and other and have other part that are the impurity. These impurity are mainly hydrogen sulfide, water vapor, siloxane, and hydrogen. For that reason, the biogas always considered a dirty gas that requires prior cleaning in order to be used as raw material for energy production or for another product like biomethane, hydrogen, or methanol. According to its production, we can find currently two kinds of biogas. Biogas coming from uncontrolled process, for example, landfill gas, and biogas coming from controlled process, for example, wastewater treatment plant and other kind of product by the digester process. What kind of impurity are found in the biogas stream? In the biogas stream, we can find two kinds of impurity: external impurity and internal impurity. External impurity, they are no part of the biogas fluid, it not belong to the biogas fluid. And in this kind of impurity, we can find sediment, foam, particle, and condensates. And in this case, the biogas cleaning is defined as growth removal, because this growth removal is useful for define in third time the biogas fluid. And the technique for removal this kind of impurity are mechanical operation like filtration and change in the hydrodynamic condition of the fluid. For example, change in dimension or change in direction of the biogas fluid. The other impurity, the internal impurity, they are part of the biogas fluid, belong to the biogas fluid. This kind of impurity removal by technique, by physical, chemical, biological, or combination of them. And in this internal impurity, we can find water vapor, siloxane in the case of study, hydrocarbon, and hydrogen sulfide. In this case, the biogas cleaning is defined as polishing or fine removal. What is the siloxane? Siloxane are compounds created by humans. For that reason, appear in many industrial products like domestic, food, plastic additive, clean product, and so on. We can distinguish two kinds of siloxane. Siloxane properly said is an organic silicon functional with functional group silicon oxygen silicon bond, and Siloxanes. They are a polymerized siloxane. How appear in many industrial products is to expect that the siloxane can be found in wastewater or in urban solid waste. What happened with them? That when you use, in this case, the slag coming from wastewater treatment plant or the municipal solid waste go or submit to the anaerobic digestion, in this case, the siloxane are realized and incorporated inside on the biogas fluid. Actually, there are two types of siloxane, cyclic siloxane. It is labeled type D, and linear siloxane labeled type L. And with the family in this case, you see, with her family, his family in this case. D3 up till DC, L2, LC. This is the structure, the chemical structure unit of the linear siloxane and the cyclo chain siloxane, type L and type D. What is the effect of the siloxane? When you use to biogas to produce energy, you use different machines, for example, engine, turbine, or boiler. In this case, as result of the combustion process, appear the silicon oxide. This silicon oxide is a solid material like fine sand. And for that reason, the effect over this machine is in lake the engine increase the current between moving part and feed part and lose the lubrication oil. If the siloxane have any halogenate group, for example, chlorine or fluorine, appear then the acido chloride formation, and acid chloride is another effect. In this case, the oxidation of the oxidation of the internal part of the engine, turbine, or boiler. And here in this feature appear the deposit of the siloxane, the silicon inside of the engine, in the turbine, and the steam boiler. What are the current techniques for removal siloxane? Cooling, absorption, washing with reagent, and combined technique. In this case, in cooling appear to cooling up to 4 Celsius degree is the most useful technique in this moment. So cooling up to -25 Celsius degree. In absorption, active carbon, membrane, or silica gel or aluminum filters. In the washing reagent, methanol is used. Is not useful currently, and combined technique when you combine, for example, drying or cooling by active carbon to get this kind of technology. Is the BTH MP drive is our development for the biogas clinic in this case. This is the case of study, yes, in the Butalque wastewater treatment plant here in Madrid, Spain, and BTA's MP Dry is the brand of our product. Biogas treatment system, multi-purpose plant, based on dry technique. Let me explain in brief word how working our technology. Here you can see, please. Here you can see our fluid diagram. And here you can see the photo of our technology. The technology has two main parts. One related with the cooling, and one related with the polishing or active carbon filter. The cooling system has two cooling system. In this cooling system, we have the heat recover. With the heat recover, we have to good result, because due to the recovery energy here, we reduce the energy consumption of the chiller, and for in other side, we reduce to the relative humidity of the biogas go into the carbon active filter. For that reason, the performance of the active carbon is better, and the quality of the biogas cleaning is high. The second cooling system is this equipment. There are two cooling systems, indicate thermal cooling and mechanical cooling. Thermal cooling is because put in contact, in direct contact, cooling water with biogas, and after, due to the condenser, appear the mechanical cooling. Then the cooling biogas put in contact with the hot biogas, minimize the energy consumption and minimize the relative humidity of the biogas. And for that reason, under this condition, the biogas get into the pollution system, in this case, active carbon filter. This technology can work in pressure line or in vacuum line. Okay, is working in vacuum line. We need some system, some device to remove the condensate forming in both equipment. This is the photo. In the photo here appear the cooling system with and cooling, chiller, screen control, and the active carbon filters. What is the condition are working with this technology? In this case, with the working temperature in the biogas outside of the cooling system to Celsius degree. The condition is the input condition is biogas fluid, in this case, biogas temperature and biogas fluid. And with this system, before seeing, work to working at 2 temperature. When we work at 2 temperature, according to this chart, that relay the siloxane removal versus temperature, we can, is working to Celsius degree. Yes, in this case, we can removal up to 40% of the siloxane contained in the biogas fluid, mainly the siloxane type D, D3, D4, and D5. And in this case, only the siloxane type I is passed to the active carbon filter. This is the result of the application of the technology before BTA's application and after BTA application. There is a decrease in the siloxane contained in the biogas fluid. For that reason, decrease to the silicon in the biogas tube. And in this case, is after applied BTAs as technology for biogas cleaning, decrease from 1.99 to 0.03. And at the same time, decrease to the silicon. It decrease the siloxane in the biogas, and for them decrease the total silicon. To expect that the silicon contained in the lubrication oiling decrease to BTAs after BTAs. BTAs, this is the level of the silicon in the oil, lubrication oiling. And after apply the BTAs, this is the level of the siloxane contained in the lubrication oil. Actual of this application is the estimate approximate cost of mantenimiento saving of the biogas engine, in this case, when the biogas is used for energy production via engine. Okay, in this case, the orange behavior belong to the mantenimiento cost without BTAs. The blue behavior belong to the mantenimiento cost with BTAs, and the row the yellow row belong to the mantenimiento saving. For that reason, on 10 years, this is the amount that can be saved or in this when you use this kind of technology, or you are or you cleaning your biogas before using. In this behavior, no include in this cost, not include the environmental profit by the quality of the exhaust gas emission. As a result, with the biogas cleaning, we can get optimal machine working, reduce the mantenimiento costs, the long useful life of the active carbon. This is the critical point in the operation cost of the technology, low OPEX of the technology due to reducing the energy consumption of the chiller and increase the useful life of the active carbon, and the high quality of the biogas cleaning. Thank you for your attention. I am here for any question.
So, is there any questions regarding?
I just put a question in the chat.
Yes.
I think it'll be easier for you to read it than to try to listen to me.
Yeah, Dr. Joaquín, will you see the message in the chat? Message is there
in the chat.
Yes.
Let me see the chat. No, I don't see any question in the chat.
So the question is,
you can read this.
Let me read my question.
Okay.
First off, thank you, Dr. Joaquín. And I'm wondering, what are the chemicals in the biosolids that end up being converted into siloxanes in the biogas? I'm wondering if the chemical sources are natural, such as silicas and silicates, or are they caused from humans, such as silicone polymers? I'm wondering if we can, if it's from humans, can we make smarter choices in what we buy and use, and ends up being in the biomaterial that's made in the biogas to minimize the problem?
Yes. Okay.
another question from so there is another question from Jeffrey Shaw. One problem with silanes and siloxanes is the use in many products.
Yes, the siloxanes are present in many industrial products, like domestic, food, plastic additive, and the cleaning product. Yes, some human and for the house too. And this is could be two kind of this compound, siloxane propylene and the silicone. But in this case, that the mainly that here in the biogas, both in the waste treatment plant and in the urban waste, the siloxane. And the problem is the siloxane in the chemical structure as the silicon atom. Okay, and when this kind of material and take into account that the siloxane are part of the volatile organic compound. The volatile organic compound are fuel component too. And when this kind of material enter in the energy production via engine, via turbine, or via steam boiler, due to the combustion, this molecular structures break down and appear and produce, in this case, the silicon oxide or silicon alone, and is the behavior or the feature of this component is like sand, like thin sand, and for that reason inlay and deposit in internal part of the different machine involving in the energy production or in the other product production. And this is a very big problem. This is both siloxane and hydrogen sulfide are two main components. These are the two main components. They are very dangerous for the biogas use as energy production of raw material for another production like biomethane, like hydrogen, and like methanol. For that reason, both people relays or staff relay or company relay with the biomethane production or the energy production always ask you, your biogas cleaning or no cleaning? Your biogas need cleaning or no? And he deliver you a technical specification paper to guarantee the good working of the technology or the machine involving in the application or use of the biogas.
Great explanation. And so, any questions? So, anyone wants to, yeah, contact Mr. Dr. Joaquín Reina if anyone wants to.
Thank you so much.
Use his technology or test, or he did excellent research and his presentations are.
Thank you so much for the opportunity to explain and expose our work here on the biogas field. Thank you.
Yeah, thank you very much. And there any other